before we get started, are there any going into this? Does anyone have any kind of questions or anything they've struggled with in regards to database, or any stuff that they kind of would like to touch on today, if possible? I might know the answer, I might not. So are there any kind of SQL database related questions going in?
Well, I just wanted to see if you could give some tips before going into your class next quarter, like how to get prepared.
Which class are you going into?
Which internet applications?
250. Okay.
Yeah.
So what we're going to talk about today will be in 250. So even just what we're going to go over today, that will be applicable. Yeah. So
okay, sounds good.
In 250, we're building a full application back to front from the database. And in that class, by the front end, I'm meaning it's a web page, but it could be a full stack app, could have anything on the front end. But so you will be designing a database, connecting it to an application. And so hopefully this will be applicable. So this should help.
Sounds good.
Do you have any questions, Dylan?
No, I was just going to say I can't really think of anything off the top of my head, but I'm sure I will have some as you go along.
Okay. So real quickly, before we get started, one of the things I wanted to touch on where students get confused, and I apologize if this is review for everyone, but a lot of times I see students not quite understanding what a database server is versus what they're using to interact with that database. And what I mean is there's a difference between Sql Server, okay, and that is what's actually processing the queries, it's actually taking in and giving a response, and Sql Server Management Studio, which is what you, the developer, are writing your code in. I think a lot of times when I would ask students to install Sql Server Management Studio, they'd install Sql Server, and then they wouldn't understand why they couldn't talk to their database. So when we have a server that we're installing, Sql Server, MySQL, any of those, that is running on your computer. It's running in the services. If you actually hit I'll go ahead and screen share here. If I actually hit I already have it pulled up. Cool. So this is all the services currently running on my desktop. If you want to look at this, you can hit the Windows key and type services, and you should get this little services app. Another way to get here is to go Windows R. This is a shortcut for run. So the Windows key and R, and you can run services.msc. And this will tell you everything that's currently running. There's going to be all kinds of stuff here. But if we scroll, it's alphabetical. We can sort this alphabetically. And if we scroll down here, eventually you're going to see Sql Server. We have Sql Server running on the computer. And that's what's actually going to manage your databases. It's going to take in queries. It's going to send back information. For those of you who have taken the database classes here at RTC, you have worked in this Sql Server Management Studio, which popped up on the wrong window. That's kind of annoying. You have worked in this. Does this look familiar to everyone? Yeah, hopefully.
Yes.
So this is not Sql Server. Okay, this is like Visual Studio for talking to databases. Okay, so if I need to write a query, I'm going into Sql Server Management Studio. If I need to check the contents of a table, I'm going into Sql Server Management Studio. If I need to delete a table, I'm in here. If I need to create a new user account, if I need to lock someone out of my database, if I'm working on, for some reason my database won't connect and I need to go look at what port it's running on. Okay, then you're actually going over to the server itself. As a developer, you're going to spend 90% of your time in something like Sql Server Management Studio or some other client to talk to it. Now, before we go any further, just wanted to talk about a few different database options, and they're all good. Okay, there's not a lot of bad choices here. So you might have heard of SQL Server versus something called MySQL. MySQL is incredibly popular. You can just Google MySQL, mysql.com. The really great thing about MySQL, it's a SQL-based relational database, similar to SQL Server, but it's free. And I have to clarify the free part because people get confused again. We're in this SQL Server Management Studio is free, but that doesn't mean that SQL Server itself is free. So for example, if I was building a web server today, and I was going to set this up, I'm going to wire a T1 line into it, I'm going to host all my stuff. On that server, if I wanted to host a database, I have to pay for a server to host it. And if I go with SQL Server, that's not free. MySQL is. MySQL is completely free. This is a great choice if you're making a smaller project and you don't know if it's something you're going to be able to monetize, you just want to get it up and running quickly. MySQL is a great solution. It runs a lot of fantastic stuff. One of the things I really like about MySQL, when you download it, it's really clear that you're separating the server versus the development environment. So if I think it's MySQL community is what you're looking for. This is the free stuff. So if you just Google MySQL community, you'll get this. And I'm just going to go to this installer for Windows. Here's all this stuff. It's a little confusing at first. Hey, what do I need? I'm trying to install this. What is all this junk? You can just go MySQL installer for Windows. You can download this right here, 440 megabytes. And once you install this, I wish that the SQL Server one was this clear. But when this installer launches, it actually asks you, okay, what do you want to install? And this is what I was talking about, the server only. This is the thing that runs in services that actually takes in the SQL and sends back a response. If you install server only, there's no way to write queries in here. Okay, this is the host. Client only, this is going to give you MySQL Workbench. MySQL Workbench is the MySQL equivalent of SQL Server Management Studio. It's very similar, really powerful. And you can just click this developer default here, and it'll give you everything you need to get up and running with MySQL. It'll give you a server. It'll give you the workbench. You can also use the shell if you want, but to get started, I would recommend just installing developer default, going into MySQL Workbench. Now you can play around with it. You can create databases, create queries, same way you did in SQL Server Management Studio. Really good option. If you go to Azure or AWS to host your app, both of them have a MySQL database completely free of charge. It's part of the free services. It's free forever. So really great. If you go on with SQL Server, it's still pretty affordable. It's not expensive. It's a few bucks a month. If you set it up right. If you set it up wrong, you can spend a lot of money by accident. But if you set it up right, it's just a couple bucks a month. But still, a couple bucks a month is infinite percentage higher than zero. So really, MySQL, really good option. Now on the SQL Server side, so the downsides with MySQL, SQL Server does outperform it, and there's not a whole lot of getting around that. SQL Server is fantastic. Now, SQL Server has to run on Windows. And I think that's actually not true anymore. Up until very recently, it had to run on Windows. So that was always people always went MySQL if they were hosting on a non-Windows machine. But SQL Server in general will outperform it. And the reason why we primarily teach SQL Server at RTC, SQL Server is very, very widely used in large enterprise companies. If you're a small startup, you're probably not using SQL Server. If you're a big established company and you just want something reliable, easy to use, and fast, they're probably on SQL Server. Now, again, if you install this SQL Server developer, this is just the server. This is not as clear on the MySQL side. You know, MySQL told us, hey, you're going to get the client and you're going to get the server. If I install this, this is just the server, no client. You have to install SQL Server Management Studio separately. They're two separate things. Now, if you want to start playing with SQL right out of the box, as long as you have Visual Studio installed, you actually have a SQL Server installed. It's a small instance called local DB. And as soon as you install Visual Studio, even if you don't check the database options, even if you just check the basic options, it installs itself as part of Visual Studio. So if you're not setting up a SQL Server, if you're not going to need to set admin access, all that, if you're just playing around with databases, you don't even have to install this SQL Server. You can just install SSMS and start connecting to your local DB and just start playing with stuff that way. And you don't have to mess with this, and it kind of makes things a little less complicated. Any questions about any of that so far? So there's a couple more options that we're not going to really demonstrate too much of as far as databases go. There is SQL, which is relational databases. It means that you have these tables that are related in some way. A customer has an address, an order has many products. There's a relationship between them. And this works great. You know, there's a little bit of a learning curve getting used to defining those relationships, but it's fantastic. It's logical. It lets me get to someone's order history from maybe their street number address, you know, through these related tables. It means that when we get a response from the database, it's logical. We're not just getting a big blob of text in our application that I have to go through and find what I need. The competing products currently that are new and really exciting are what are called Nosql. Mongodb is Nosql. And these are closer to big blocks of JSON. It's really like storing a whole document. And the advantage here, there is a point where a relational database starts to break down in efficiency. Now, I have never built anything large enough to see that. It's a huge, huge amount of data they can handle. But let's say we are Amazon. And we are Amazon, and we need a database that's going to keep track of where every single Amazon truck goes every single day, or where every single person clicks on our webpage every single day, and where they click next. And we're trying to analyze what products are going to buy based on where they've been. That data gets out of control in a hurry. And when you get into this world of big data, a lot of these big newer tech companies, they're on MongoDB. And the real, what you can think of as a real simple explanation for the advantages of MongoDB. Eventually, let's say you have a table and you're up in the, you're adding 1 million rows to that table every hour. We're in the world of big data now. We're constantly generating data. Google phone tracking data, keeping track of where we're all going. You're adding nonstop. Eventually, that table, if you're in a classic SQL relational database, is not going to perform well anymore. And there's no amount of indexing or hacking you can do to make that table more efficient. And so in that situation, if that's the kind of app you're building, you're probably looking at a NoSQL solution. In the world of NoSQL, If a given table has too many entries, we just make another one. And that's fine. Everything's cool with that. If I have a customers table in a relational database and I make a customers to table, I just broke all the rules. I can't have, that's not going to work that way. So that's NoSQL. We're not going to do any NoSQL stuff today, but it is new and interesting. If you go and you work with, go get a job at a kind of upstart, newer tech company, there's a good chance you're going to be working in NoSQL. But if I were sitting here hedging my bets, I would learn SQL first, and it's just because when you're new and working in computer science, there's a good chance you're coming onto an existing project, and the overwhelming majority of existing projects are going to be using SQL, and a lot of them are going to be on SQL Server if you're at the enterprise level. All right, any questions about any of that? So the next thing I wanted to introduce is let's expand tables. Think about it this way: in MySQL, in a relational database. So we won't say MySQL. We'll say a relational database. That could be SQL Server, MySQL, SQLite, anything where the tables relate. Every table has to have a well-defined relationship with all the other tables. In MongoDB, you don't have to worry about that. If I decide tomorrow, if I'm in a MongoDB environment and I'm working at Amazon, and I decide tomorrow I want to collect 3 more columns worth of data, I just add it to the document that I'm storing. I don't even have to call my database developer. It's cool. We'll just start collecting it. Now, if we're in a relational database world, if we need to change what kind of data we're collecting, we got to go work on the database first. We're going to have to add those columns, define those relationships, figure out how those columns relate to everything else. So if your data is really set and it's easily relatable to one another, then you're in a SQL relationship. If you want to just be able to pull in everything and not worry about how it relates, and that's why these new tech companies and big data are so into MongoDB, because it's just so much. It's a lot easier to just pull in a ton of data and then worry about it. Using this preferred skill nowadays, no, I would still say I think SQL is still overwhelming. It depends where you go. You go to FANG, you go to these new tech companies, they're probably going to have some MongoDB projects, but everyone else is on SQL because SQL's been around for forever. It's mature. You know, if I'm running the IT department at Walmart, I'm not going to go learn MongoDB. You know, it's just there's no need for that company to be on the cutting edge like that, or Costco. I'm probably going to be using a relational the students who have left RTC to go work at the state of Washington, they're all using SQL. So SQL is very mature. It is very heavily used. It's very in demand. Really common SQL job is not even building a database. So if you get into data analytics where a person is asking questions about all the data this company's ever collected, you got to know SQL, because as you go back, they might even have a new project they launched in the last 5 years that's on NoSQL, but all the data they generated from 1970 to 2017, that's in a relational database. You know that. So at this point, I would learn SQL first. I'd add on some NoSQL. SQL is still extremely in demand. My buddy's an accountant. He's not even in IT, and he'll get a hold of me once or twice a month with some sort of SQL question because he can't get a hold of the IT department and he needs to know some sales numbers from somewhere, and the reports are due. So SQL's, and that's a tech company actually. They sell video games. So anyway, SQL's very, very in demand. All right, so we're not going to spend a ton of time in SQL Server Management Studio. We are not going to write a whole bunch of queries today. We're not going to select star from anything. We might a little bit, but I want to introduce you to the SQL tools that are built into Visual Studio. And the reason I want to do this, I feel like a lot of students I've talked to get hung up on how much they hate the syntax of SQL. And then they put databases down and say, well, I know what I don't want to work on. And the fact is that this syntax of SQL, yes, there's a little bit of a learning curve, but the most important thing that you're managing with a database, a relational database, is those relationships, is understanding how the different tables relate, understanding how the data relates. Do not get intimidated because the syntax is a little weird. You can always Google the syntax. You can always Google the syntax, especially in SQL. SQL syntax, to their defense, SQL syntax is weird. It's hard to remember, but you can always Google the syntax. So what I don't want you to do, I don't want you to pull up SSMS, start writing queries and thinking, okay, this is database design. Because it's really not. Okay, you don't build a database inside of here. That's not where you build a database. This is where you write queries, sure, but that's not where you build a database. And there's a lot of tools that can really make creating a database a little bit easier, where you're not so hung up on this syntax. And then if you run into problems, we can always Google the syntax. So let's go ahead, let's design a database. And then we're going to build it using a tool built into Visual Studio that I really prefer, because I have written create table customers parenthesis primary key ID. I have written that enough times in my life to be good for life. I don't need to type that anymore. I can die happy having never typed that again. So we're going to use a different tool to build our database. So let's go ahead and let's take a look at where's my whiteboard? I'm blanking. Gosh, I haven't been on Zoom in 2 weeks and I've forgotten how to use it. Whiteboard, stop share, share screen, whiteboard. All right, database design. It's done on a piece of paper, or it's done in a, if you don't like a piece of paper, you can use any sort of sketching app. There's some apps that are, you can go online and draw out a database diagram. Okay, but this database design, I prefer paper and pencil. Okay, we don't build a database in SSMS. You build a database on a piece of paper. So let's build, we're not going to build too complicated of a database here. We'll just build something with a few tables that are related to one another, and then we'll fire it up in Visual Studio. What kind of database do you want to build? Who has a suggestion? What are we selling or not selling? Cars. All right, we're selling cars. So this process of building the database, what you're doing, you're spending a lot of time sitting down with your client. Your client could be the owner of the auto dealership, or maybe this is something that goes in between the manufacturer and the dealers. And you're asking them these questions. And the questions you're asking are about how the data relates to one another. So we'll just pretend we're building a database for Bob's used car lot. And we're sitting down, we're meeting with Bob. And we're asking him questions like, what kind of data do you need to collect about the cars? Okay, what kind of data are you collecting about your customers? What kind of data are you collecting about your salesperson? And then once we have those tables defined, then we're asking questions like, okay, how do those relate to one another? And by relate to one another, I'm asking questions like, can a salesperson sell more than one car? And we probably know intuitively that they hopefully should, but they probably won't be there very long. But then the next question we have to ask is something like, well, can a car be sold by more than one salesperson? That one's not quite as cut and dry. That one's not quite as obvious. And where I really encourage you to put your focus is on these relationships. That's the whole game we're playing. How does this data relate to the other data? So we'll make a fairly simple one here. We'll say that we have, we'll call it a vehicles table. And we're figuring out what information they need to collect about a vehicle. Now, in relational databases, pretty much, I know sometimes in databases you will see a table without a primary key. You don't technically need a primary key for every table. There's some tables like bridge tables that don't necessarily have to have one. I'm going to tell you right now, most of the software that's going to sit between your application, your web page, your game, whatever, and the database, most of that software is going to want all your tables to have a primary key. So I would just get in the habit, the very first column in our database is going to be a primary key. It's going to be an int, and it's going to be named ID, and this is our primary key. Who wants to tell me what a primary key is? Someone knows. Come on, can't ask me to lecture on my summer vacation and not talk to me. Gonna make me sad. Unique identifying number. I love that answer. So that's that first part of that answer, unique. That is the most important thing. It could be like 1, 2, 3, 4. That's a possibility. That could be a primary key. It could also be something like this. This could also be a primary key. The biggest thing about a primary key isn't whether it's an int, a varchar, whatever. The biggest thing you worry about with the primary key is that it is unique. It's unique. We'll just use int in this example because it's the simplest to think of, but this is unique. We will never have duplicate entries in the ID column in this vehicles table. So we'll add a few more. We've got make and model. What do we think the data type is for the make of a car? String, okay? String. How do I say string in Sql? Does anyone remember?
Varchar.
Varchar. Now, I'm gonna tell you right now, I forget all the time these data types. I don't want you to be, that's another thing that I feel like students get hung up on. They're like, man, these data types are weird. How come this is called varchar? That's strange. Why is this a byte array? That's what I had to deal with before, is a byte array. That doesn't even, how's that help me? Do not get intimidated by these SQL data types. You have Google. What is a string in SQL? This is supposed to be simpler. It's supposed to be like the top one. Okay, making me look bad here. We'll say T-SQL because this is the Microsoft one. Well, it's varchar. My point is you can look all this up and you're going to forget. and don't get scared off of SQL because the data types look weird, but it's the same thing. Oh, this is making me search on Bing. This is why I can't find anything, Microsoft. Watch. It didn't. Varchar, right there. Freaking Bing. Okay. So let's go with Varchar. Or again, we're designing this on a piece of paper. If you don't remember that it's called varchar, you can just write string. It's your piece of paper. No one else is going to look at it. You can look it up later. And we got a varchar. That's going to be, I think I did these backwards, but that's okay. We got a varchar. That's the make. And we got a varchar. That's the VIN number probably. Anything else you guys want to capture about cars?
Maybe the year.
Year. Yeah. Yeah, that'd be a good thing to take. Year. How should we store the year? What's our data type for year?
Is it like date?
A
Yeah.
string because we're not doing math. Or
Yeah, yeah, it's debatable. I'd probably go with int. But you're gonna see situations where people have used a data type that you maybe didn't agree with. Maybe they use date time. That's not. I probably wouldn't go with date time. That's more for storing timestamps. But I would probably go with int. But you might see it, and that's okay. All right, so we'll stop there so we have time to get through this. But we have these vehicles. And then we have, let's say we have something called, we're gonna pretend we're selling cars here. So we have a sale. We have a sale table that keeps track of when we've sold the cars. So what is my relationship? We'll call this, we'll just call this sales. What is the relationship between a vehicle and a sale?
Would it be the ID?
So let's not talk, let's talk less technical and more just let's not think about these for a second, how we're going to tie them together. Just think in the real world example, like we're talking to someone who doesn't even know what a database is. How we're at a car dealership, how are vehicles related to a sale at a car dealership?
the vehicle's the product being sold.
Okay, how many? So if we have one sale, okay, if someone came in and they bought something, we could say that a sale has a car. Does that seem like a good way to define that? A sale is related. There is a car that gets sold.
Makes sense to me.
And this is the hard part of designing databases. All this other stuff you can Google, okay? All this varchar, syntax, SQL, but what we're doing right now, trying to figure out how the sales table relates to vehicles, this is where you put your energy. And this is what you have your meetings about. And this is what you discuss with coworkers, you discuss with the clients. Sometimes it changes on you. So we have a sale. We're gonna sell a car. Can one sale be for more than one car? What are thoughts?
Maybe it depends on how the system works, I
It
suppose.
totally depends. It totally depends. And this is the kind of thing you're hashing out with your client. And they might tell you, they might say, you know, technically that could happen, but that's not what we want. We always do, because of the way we have to record our sales, every sale has to be on one car. We do not do 2 cars in one sale. That would be a business rule that they have, and we could reflect that in our database. Now, I'm going to assume everyone's taken object-oriented programming here. If I was making a sale class and a sale had a vehicle in it, I could literally just put that vehicle in the C# class. I could have a relationship. I could have a has a relationship where a sale has a vehicle. Now, I can't do that in a relational database. I can't go right here and I can't say vehicle. Okay, that's not how that works. How do I establish this relationship in SQL? Does anyone know?
I would use an ID for the vehicle models and then as a
Foreign key. Foreign key, exactly. So when a sale, when one object has another object related to it, when a sale can have a vehicle, we do that with a foreign key. So let's go ahead, we'll do our sales table here. And again, most ORMs that you're going to work with that are going to talk between your application and your database are going to want a primary key. So we'll just make that, that's our primary key. And then we have vehicle ID. And this has a foreign key relationship over here. A sale has a vehicle. And we'll do one more, and we're just gonna we'll stop at customer. We're not gonna do any many-to-many or bridge tables. If you're in a situation where you need to do that and you need some help, reach out to me. I can provide some resources. But just for simplicity today, we'll go ahead and we'll say a sale maybe has a date that it occurred. How should we store the date? How do you guys want to do that?
String.
So there's a lot of different ways to do this, and you're going to see it done all of these different ways. There is a date time data type in SQL, in T-SQL. You're also going to see this. This is fairly common as well. Int, we'll say sales year. And I know my capitalization, I don't think they use this capitalization syntax in SQL, but int sales month. Int sales day. That works too. We could also use a date time and a date timestamp here. That would also be fine. What about the price? Where does price go? Should the sales price be over here in the vehicle table, or should it be over here in the sales table? What do you think? I agree. I think sales table makes the most sense. How should we store the price? What's the data type on the price? If you can't remember your SQL data types, you can just Google them, and you can just put in any data type that you know in C#. And we can just Google it, and it's decimal. Gives you a lot of options. So the way decimal works in SQL, it's a little different than in C#. What we have to do is we give it two numbers. The first one is the total number of digits in the whole number. So if I wanted to store, let's just say I was trying to store $2.50. This would be a decimal 3, 2. The 3 being there's 3 digits here. The 2 being there are 2 digits past the decimal point. So we're selling cars. We can kind of pick here, average car. I guess maybe we could go 6 figures, but we'll just go 10-2. It's going to be a pretty expensive car that would get to 10, but we'll just say 10-2 price. Now, what else does a sale need? And we'll skip salesperson because the relationship between sales and salesperson is many to many, and we're not going to map that out today. But what else? What other sort of table do you suppose could be related to sales? Loans. I like that. All right. I was thinking customer. Loans. Let's do it. Fun. I'm in. Okay. Loan table. And the car dealership would definitely need to collect information about this. So what's some info do you think we need to know about a loan? And we're just going to make 3 tables, so we'll leave out customer ID. This is the primary key. How are we going to connect the loan to the sale? A sale has a loan, right? What do we need? Foreign key. We'll just call this int sale. I should have probably named this sale, but int sales ID. That's our foreign key. That's what allows us to relate back to this sales table. What about the amount of the loan? Should I store that?
Yeah,
Yeah. Does anyone have any other ideas?
probably the lender.
So, and again, this is, I'm not saying that's wrong. One of the things we try to do in database, there's a concept where we don't store a calculated field. So if we have this total sales price in another table, then we might not want to store this down here. Maybe you do. Maybe they come in and they say, no, the loan table needs to have that there. But if it's something you can calculate, if I can calculate it from the existing data that I have here in front of me, I typically don't want to store it. So we'd end up asking them questions like, okay, this price in sales, is that out the door? Is that the sales price? Are we going to store the tax amount? And these are the questions we end up asking. And those answers, I will promise you this, those answers will change as the project moves on. You'll give them the first kind of minimum deliverable product here, and they'll say, you know, I think I do need to know about this data at a certain point, and you'll have to move this stuff around. I think I agree with Dylan. I think it does make sense to store a loan amount down here. But just know, if we, and it makes sense because there's tax, there's title, there's all kinds of stuff that goes in. But just know, if we're storing something that we could have calculated otherwise, we're actually being a little bit inefficient. Okay, can one sale have multiple loans? I hope not. I hope not. That's scary. And so we have these three tables. We've defined the relationships between them. We have these foreign keys that are going to let us get from one to the other. This is a simple example, and it's kind of ugly to look at, but this is database design. Typing create table and all that stuff, that's just typing the code. This is database design, and this is where you need to spend majority of your time really thinking about how your data works together. Now, if I have, for example, let's say I have a loan ID. I've just pulled some data out of the lender's database. Can I get to the vehicle that they bought with that loan ID?
I would say yeah.
Yeah. I can get the loan ID. What about if I have, if I have the vehicle ID, can I find out what loan they got? Yeah. All this data is related. It's related in a way that makes sense. Now, your data, and in this example, it's 2 tables. Your data might be 5, 6 tables away. And that's okay. That works. The query is going to be complicated, and when you're writing that query in SQL Server Management Studio, there's going to be some. It's probably not going to work first time you hit enter, but that's okay. You can always when you get stuck on that SQL syntax, you can always Google it and you can find it. So let's build this database, and like I said, I am not going to create table in SQL. We're going to use the built-in tools in Visual Studio. They're really easy to use. They're really powerful. So let's go ahead. Let's fire up Visual Studio. And when I screen share, this is going to go away. And I don't want that to happen. The other, and when I'm working on the database, I have this sketched out. And I leave it up there because I will tell you, the second I stop looking at this, I'm going to completely forget. I'm not going to remember this for 10 seconds after I look at it, especially when you've got a really complex database design. Keep that diagram up. Even when you're writing the application side, you're going to forget. You're going to be 6 tables away from what you need, and you're going to forget how to get there. So when I'm working on a project, I have this image printed out, and I just keep it next to it. So let's stop screen share. Oh, open my email. Nice. Where'd you go? There's Zoom. There it is. Don't need services. All right, so the first thing I wanted to introduce you to in Visual Studio is SQL Server Object Explorer. And what this is a small tool that it's kind of like a mini SQL Server Management Studio, and it's built right into Visual Studio. It lets you kind of glance at databases without firing up a totally separate application. And you can pull this up while you're in any project too. And I'm not even going to make a project here. I'm going to click this continue without code button. When you click continue without code, this just brings up Visual Studio. If you need to change like your background color, or you're installing different tools or something, and you just want to open Visual Studio without any project open, you can just click that continue without code. And the way I get to SQL Server Object Explorer is I can click View, SQL Server Object Explorer, and this is going to fire up, and it's going to give you all of your SQL Server instances that you have installed. If you don't see yours, you can click Add SQL Server. You can go to Local, and it'll scan for you. This MS SQL Local DB, this one right here, this is the one that gets, as soon as you install, everyone should have this one. As soon as you install Visual Studio, this comes with it. If you don't see it, go ahead, click that connect, go to browse local. You should see it listed there. Some of you might have other ones here. That's where you have installed SQL Server Development Edition in the past and set up some databases. And you can expand these and you can take a look at them. We can also look at the data inside of it if you want. I think this, where's the school one? I know the school one has some data. So you should be able to pull up any of your data, any of your databases, just expand it, go to tables, and then you can actually look at the data inside each of these tables. So I can right click on this table and I can say view data. And there's all of my information. Right click here, view data. And you should, any database you've made previously, you should be able to look at. So this is, it's lightweight, it's built right in, has a lot of the functionality of SQL Server Management Studio without having to open a separate app. Did that work for everyone? Any questions about that? All right, so we'll revisit this in a little bit. The next thing I want to introduce you to is the database. What's it called? Why aren't you searching? One sec. I want to relaunch Visual Studio. It's a little weird. There we go. I don't know why that wouldn't come up. So if you go File, New Project, and up here you just type SQL, it should filter, and you'll get a SQL Server database project. This again should just come built in. You shouldn't have to install any additional tools and features for this. And we can create a database here. Just going to put this in a temp folder. And what did we do? Cars. And I'm going to call this cars DB. Visual Studio's being really slow. So, and essentially what this is a database builder that we can use right inside of Visual Studio. We don't have to do create table. We don't have to write any of that. We can do this right out of here. And when you have this project, just sitting here, the cool thing that you can do with it is I can just point this. When I go to deploy this, I can just point this at any SQL server that I want and just publish it, and just push it up there. I can push it up to my local MS SQL local, or then when I decide to take it online, I can then just publish it right to a web server. So what have we got here? We just kind of have a little bit of an empty solution over here on the right. I'm going to go ahead, I'm going to make some folders. So I'm going to right click on the project, which is this cars DB. And we'll say add new folder. And I'm going to call this DBO for database owner. And then we'll add one for tables. Now, we're just going to make the tables today, but I could make stored procedures in here. I could make triggers in here. Anything that I'm wanting to build for my database, I could build this right in here, and then I can publish it wherever I want. And what this will do, and we'll take a look at it at the end, this is going to generate the SQL script for me. So I don't have to sit there and write all of this SQL. And you still have the option, if you would like, to go back and modify that generated SQL. So I'm going to right click on this tables folder and I'll get an add. And here's all of our options. Here we could add a stored procedure if we want. I'm going to add a table. And see, I already forgot. I don't even know what we're making anymore. Vehicles. We're adding a vehicle table. And I'm going to name this vehicle. I know we typed vehicle. I know we typed vehicles and sales. It's just my preference. I like to name my tables singular. You'll see both. You'll see databases where this table is called vehicles, and you'll see databases where it's called vehicle. The reason I prefer singular is because for me, it's easier to remember the relationship if it's singular. If I say, how do vehicles and sales relate? That's harder for me to figure out. But if I think, how does vehicle and sale relate? That's easier to me. Oh, I got a one-to-many or a many-to-many. One customer can have many products. So that's just my preference. I like to name my tables singular. You don't have to do that. Now, what has come up? We have this table. We have vehicle.sql. So you can see we're actually writing a SQL query. And we have at the bottom here, we have create table. Okay, so this is the SQL that's being generated by what we're doing. So these are my columns. We have an ID, data type is int. It's set as the primary key by default. There's one other thing we need here to make this a primary key. We would be typing right here. Does anyone remember? Is anyone SQL real sharp? What am I missing?
Auto increment.
There we go. Hey, 10 extra credit points for the class where the score doesn't count for Dylan. Nice job. All right. Now we could type that, or in here we have this cool designer. And if I want the whole column, I usually click off to the left here. It gives me the whole column. I can right click on this. I can say properties. Oh, where'd it go? Right click properties. Hold on. So the properties opened over here. The reason why it's not popping up. If you get into this situation in Visual Studio, here's how I prefer to work in Visual Studio. We have all these panels off to the left and right? I pin open the ones that I want to see. And so right now, I'm going to pin down that Solution Explorer and I'm going to pin open properties. And that's what this push pin button does. It toggles whether the thing hides or not. And if I'm working in something where I want properties to be revealed, I just pin it open. If I want properties and Solution Explorer to be revealed, I pin them both open, and then I get one on top, one on bottom. So we'll work just like that. I want to be able to see properties. I want to be able to see Solution Explorer. They're both pinned open. So again, right click on this column, properties. And now if we look down at properties, we have this identity specification. This is where we set this auto increment. I can say true, and I'm going to get identity. It's going to start at 1. It's going to go up by 1 every time. If you would like for it to start at 10, you can change this seed. If you want to go up by 10, you can change this increment, but we're going to start at 1. We're going to go up by 1 every time. We can see all the other properties here as well, and we can change them. You know, we can determine whether a column is nullable. We can change its data type here. You could build the whole thing from this properties if that's what you prefer. Okay, so we're good to go there. Gonna make a new column, and we decided we were gonna name this one model. And we decided that was gonna be a varchar. This nchar, this is specific to SQL Server. It's almost the exact same thing as varchar. There's some minor differences. It's actually takes up more memory than varchar. So unless you specifically need nchar, I would just continue to use varchar. And just for sake of speed, I'm just going to choose varchar 50. Now, does every car have a model? I think so.
Mm-hmm.
So we're not going to allow null values. We're going to say, if you're going to make a car, you have to have a model. So I'm going to uncheck that allow null. So I've got not null here. Now, these rules, they seem restrictive. Go ahead and do the make here, but they're really helpful. And they're helpful because it provides us an extra layer of filtering your data. And when we're talking about this MongoDB NoSQL world, typically that's not something you're going to deal with in MongoDB. MongoDB, you're not specifically worried about whether you're collecting the data in this perfect relational way. You just want to get all the data. You want to pull it all in, and you want to make this document. So we'll do make, same thing, varchar 50, got to have it, not null. Vin, definitely got to have a Vin. Every car's got a Vin. And in this case, you might, since Vin is a set number of characters and unlikely to change, you might actually pick that exact number of characters for the varchar. But I'm just going to do 50. And then we decided we wanted a year as an int. And we'll also assume that every car has a year. And so now this is the SQL that got generated down here for me. Cool. All right, so we've got our vehicle.sql. I'm going to right click on tables. I'm going to add a sales table. And same thing, ID is int. I can just click here to select this row. I already have my properties window open from last time, so I don't have to go to properties. I can just go right down here and I can say, hey, we're going to use identity. We're going to start at 1. We're going to go up by 1. This is going to auto increment for us. Now we got to relate sales to vehicles. A sale has a vehicle. Oh, I named it sales. I named it plural. I said I wasn't going to do that. Shoot. Hold on. I'm going to change that back to sale. I wrote sales because it was on my paper. All right. So a sale has a vehicle. We have a has a relationship. if we were in object-oriented programming, but since we're not, we have foreign key relationship. Okay, and I like to name my foreign keys the exact name of the table and ID after it. I highly encourage you to do this. You're going to see examples all the time where this does not happen, and it makes it, when you're looking at a table, it makes it really hard to glance at it and figure out what you're relating to. You have to actually go look at the relationship between the two tables. So I'm gonna name this exactly what it is: vehicle ID. This is an int. Now, foreign keys. So we created the column for this. We said it's data type, but we haven't defined the relationship yet. And I can define this. I can right click on foreign keys. I can say add new foreign key. It's going to give it a name, foreign key sales to, and here I'm going to put in the table that I'm going to, foreign key sales to vehicle. And then it's going to create the constraint for me. And all I have to do is fill this out. So we decided that a sale can have a vehicle. So all I'm going to do, I'm just going to say this foreign key vehicle ID. So I'm going to replace this column with vehicle ID. References, where does it reference? Well, it references the vehicle table on the ID column. And now I've created a foreign key and I've got this constraint. Now the relationship is defined. All right, then we decided we wanted an int. Oops, sorry, sales year, int. Int, not nchar. Sales month, sales date. And we wanted the price of a decimal 10.2. And they're saying, giving me 18.0, I want 10.2. We could probably go higher here, who knows? Maybe the place ends up selling boats or something. And we've got our sales table in, and we have this relationship defined back to vehicle. Triggers can also be made here. I don't know if you guys ever worked with triggers. They're pretty handy. The syntax is weird. Really easy tool for making triggers if you have to set up any of those. Then we decided we're going to have a loan table. So right click, add table. And we'll call this loan. Same thing, the ID. Switch this to identity. We get this auto increment. And we decided that we need a sale ID. That's going to be an int. And I can define that relationship. I can go to foreign keys, right click foreign keys, foreign key loan to sale. And we just tell it what column, sale ID, references the sale table on the ID column. Why are you mad at me? Sale ID references sale unresolved tvo.sale sale ID. to sale. That was weird. I'm pretty sure that was exactly what I just had, but okay. Loan amount. We decided we wanted the loan amount. And that's going to be a decimal 10-2 as well. Now it's mad again. Did I set the sale ID?
If you look at the top, create table DBA, DBO dot, it still says sales, not sale. At the sale.sql file.
Oh, thank you. Thank you. Nice catch. There we go. Right. So this database is built. We've got our relationships. And now I'm going to save this project. And now I can point this at any SQL Server I want and deploy it. So I can say build, publish. And so this is just asking me, okay, where do you want to send this? And the way that we talk to different databases is through something called a connection string. If I had that connection string, I could just paste it in right here, or I can also click this edit. I can use this browser to just kind of go pick my database. But if we had the connection string, we could paste it right in there and it would work. So I want to put this, so I'm going to click, this was a build publish, carsDB, edit, then click on browse, local, this is all MS SQL local DB. This works fine if you're just testing. If I wanted to go to a web database, I could click this network and then I could paste in the URL or the location of the server and my username and password. I could do that down here. So we could push this up to a web server. But I'm just going to go to local DB. As soon as you click this, all this information is going to populate. And this is my connection string. This is how applications talk to databases. What's the data source? Okay, this is the name of your server. It's the same as the name of the server up here. Integrated security, what this means that this is on my local machine. Since it's on my local machine, I don't need a username and password. If I was talking to an online database, we wouldn't have this integrated security here, and I would have my actual database login and password here instead. A lot of this other stuff's really optional. I ran into one problem with a student where this connection timeout was goofing them up for like a month. It was kind of a crazy problem. I think Will was working with that student too. Most of this stuff is optional at the end here. What you really need is the data source, and you need a way to log in. And that's what we've got with integrated security. Now we can pick a name for our database. And I'm just going to call this CarDB. That's fine. It's a fine name for it. We can call it anything we wanted. And then there's two ways we can do this. We can say publish, and then it's literally just going to go to the database and put it there. You can also say generate script, and this will give you a SQL that you can just copy and paste. So maybe, let's say you're trying to publish this, and for some reason your connection string isn't working. You could just generate the SQL script, copy the whole thing, wire into the database another way, and paste it in to create it. So we'll just say publish. And so when it's done, we've got, now we can still look at this script here. We can say view script, and this is what it generated for us. And here we have our create tables. Got the primary keys. We have the foreign keys defined. And that's our SQL script that just ran on our database. Now, I should be able to go in and look at this database server any way I want and see my cars there. So let's see, what if I go in through SSMS? Let's see if I can see it. So we'll say connect database engine. This is on local DB databases. And there it is. There's my car DB. Now that we've pushed this up, one of the things that SQL Server Management Studio does better, in my opinion, than this built-in one, I always generate my database diagrams in SQL Server Management Studio, and I do this right away. And I do it so I can get rid of this crappy, ugly thing that I've been looking at. And so I'll right-click New Database Diagram, and this is what I'll keep with me as I'm developing. It's pretty simple at this point, what we have here, but it's, you know, a larger project. It gets really easy to lose track of what you're doing here. Can you create databases through VS Code? I have no clue, but I would not doubt there are so many extensions for VS Code. I would not be shocked at all if there was something like SQL Server Object Explorer. David might know. David, have you used any SQL extensions with VS Code?
I know that they exist, but I haven't used it. I know that you can set up SQL or sorry, VS Code to have the same exact functionalities as Visual Studio. So I'm assuming that there isn't any reason why you can't use a SQL like this extension in Visual Studio Code either.
Let's explore.
Yeah.
Yeah, there you go. Users. I don't know how similar it would be, but there's something, I'm sure. All right, now we have this database. This database is up and running. And let's say I want to put some data in it. Yeah, I could go in here. I could right click on my car DB. I could say new car, and I could say insert into dbo.loan. And again, I've done this enough times in my life where I'm good. I have no desire to write this. So what I typically will do, if I just need some seed data, we can use this SQL Server Object Explorer to put some data in our database. So I can just go right here, cars DB. And again, just to clarify, I'm on the SQL Server Object Explorer. If that's closed for you, you can go to View, SQL Server Object Explorer. I've got my tables. You might have to refresh this, which is right up here, to get your tables to show up. And I can just expand this table. And no, that's not it. It's not view code. There should be a view data here. Oh, I'm in the project. Sorry, I was in the wrong spot. Okay. Up here. So this is the project itself. If I actually want to look at the database, it's under this section under SQL Server. So local DB, MS SQL, databases, there's car DB. Here's tables. So this is where you need to go. If you're down here in this projects, you won't be able to insert data. So car DB, let's go to the vehicle table and we can right click it, say view data. And I can just blast away here. I'm gonna say Ford, Mustang. The VIN is 3B. And it's a 2020. and it will insert this. As soon as I click on to the next one, it's going to try to run an insert statement. It could fail. If it fails, you'll get a message telling you, hey, that didn't fit, or that's not the right data type for so and so. If I tried to go to year here, let's do another one. Let's do a Chevy Camaro, and this VIN is 2D. If I go here, years and int, and if I try to type 7 as text, I'm going to get an error message. So it actually is inserting this data as I type it. And so now we have 2 cars in our database. And if I go back here, might have to refresh a few times, but if I go to my car DB, I should be able to right click on the vehicle table, select top 1000 rows, and there's my cars that I put in. So, big kind of takeaways from today. I really want to encourage you, if you've worked with databases and taken a database course or whatever, and the syntax freaked you out, you just I feel like a lot of students get scared away from databases. There are so many tools to interact with these. You do not have to sit here and just be blasting away at this SQL stuff all day long. Now, there are times where those tools aren't going to give you everything you need, and you are going to have to go into the SQL, and you are going to have to do some Googling and probably some research on the problem. But don't get scared away from SQL just because the syntax is strange. There are so many different ways to talk to it. You can talk to it from Visual Studio. You can talk to it from something from SSMS. There is MySQL Workbench is a great tool for talking with MySQL. And Ivan, I would start with SQL, but that's just my opinion. There are other people who would tell you to start with NoSQL. The reason why I would start with SQL, it depends where you end up. You are likely, as a new hire, to be pulled onto an existing project with legacy code. And typically, there's a higher chance that one of those is going to be using SQL versus NoSQL. Now, there's always exceptions. You could your first job might use SQL, it might not. But I would use SQL first. SQL is still, it's been around forever. There's so many jobs you can do with some SQL knowledge. So I would do SQL, and then I would pick up a little bit of NoSQL along the way. But again, just my opinion. So that's kind of some tools where you can sit and you can generate databases. Now, how do we talk to this thing from an application? There are a lot of libraries that will do this for us. Almost every development stack has one. If you're in Android, I think it's called the Room or Room database. If you're in .NET, it's Entity Framework, and there's multiples in each one as well. There's a pretty commonly used one in .NET called Dapper. And what these libraries are, they provide a way for your application to pull data out of the database, and then the more advanced ones will turn that data into objects in that language for you. So if we're in C#, it's going to turn it into C# objects for you. If you're in Java, it's going to turn it into Java objects. And what I mean by that, I mean that these vehicles will be a C# object with an ID of int. The model's not going to be a varchar, it's going to be a string. Make and model are going to be a string, the VIN's going to be a string, and the year's going to be an int. And you can work with those and treat those objects just like you would any other C# object. And then you can make your changes. And then when it's time to ship it back to the database, this object relational mapper, this ORM, will generate the SQL for you, and send it back to the table. So I kind of thought we'd get into that, but we're running on an hour and a half here. We could get into that a little bit, or we could call it for today, and we could do that another day. I'll leave it up to you guys. What do you think? Yeah. I mean, we've been going at it for an hour and a half here. So why don't we table that, and Will and I will set up a time, and we'll start talking to this database from a C# application, and we'll talk about the different ways we can do it. We'll do it the old way, because the old way was you're going to work on code that still works that way. Literally, they used to make a C# class that had all these strings that were queries, select star from as a string, blast the database with that, and get a response. And then we'll do it a more modern way as well, where we're not literally writing SQL in our C# code so much. And we'll do that next time. But thanks for hanging out. I appreciate it.
Yo, Joshua, where
Yes.
can I access the recording?
That's a question for Will.
Yeah, no worries. Yeah, I'm gonna go ahead. After we get done here, I'm gonna upload it to YouTube right away. I'm gonna put it on I'm actually just gonna send out an email with the YouTube link directly, so you'll have it within the next half hour or so.
Perfect. Thank you.
Welcome.
Any other questions? All right. I guess that's all I got to say.
Yeah, I wasn't here for the beginning, but when you're I was wondering when we're actually gonna end up connecting to the database, what kind of projects are we gonna be using?
We can do it with any, I was going to do it the old way with like a console app, just to show that it's possible.
Okay.
It specifically does not matter, especially since we're in .NET. The whole advantage of working in a software framework like this is all of your code is similar and shared. So we could wire in with a console app, we could wire in with a web page, we could wire in with any project, any .NET project that you can think of. You can use these tools to pull data from the database.
Okay. Well, whatever project we're gonna be using to connect to the database, can we not do the NVC? An MVC project. So
Sure.
yeah.
What do you want to do?
Controller? Huh? Oh, just like a console app would be perfect.
I don't think we're not going to go into the MVC.
Yeah.
This is just pulling data out of it. Yeah, we're not going to go as far as MongoDB controller.
Yeah, if you can break it down, like from the things that we learned in your class, down to like something more more simple, like a console app, I think that would be super helpful.
Yeah, we'll start with a console app, and then we'll do one. We'll do one using EF, because they used to do it with SQL connection, and so we'll do that first in a console app, and then we'll use EF for something. I don't know what. We'll figure something out.
Awesome.
All right. Well, I suppose that's it. Hey, David, have you seen the emails about the project for the summer?
Yeah.